Hello everybody and thank you for joining the webinar today. I am Kavya and I head marketing at RapidValue. I am also the moderator for today's session. This is a joint webinar by RapidValue and our IoT partner Cupola Technology. We will be presenting on creating intelligent assets for operational excellence with IoT. We have two speakers, Mr. Sudama Vemuri, Director of Sales and Marketing at Cupola Technology, and Mr. Rakesh Rajan, Lead Consultant IoT Practice at RapidValue. This is a live webinar and we are recording the session. The session will be split into two parts, 45 minutes for the presentation and 15 minutes for question and answers. If you have any questions, you can raise your hand or type your message in the chat window. The agenda for the session is as follows. We will talk about the key trends impacting businesses across enterprise IoT, how to build intelligent assets and how to overcome the challenges. This we will explain with real-world examples. We will discuss some of the top 5 industry-specific use cases across different industry verticals and how to create a plan to deploy IoT-enabled solutions. Now I would like to invite Sudama to take over and present his session.
Thank you, Kavya. Hi everyone, it's a pleasure to have you all on the bridge today. My name is Sudama Vemuri and I head sales and marketing for Cupola Technology. Cupola is an IoT engineering company that was founded in Feb 2011. In fact, we are celebrating our 6th anniversary this week. And over the last few years, we have built IoT solutions for a number of industry domains, including manufacturing, telecom, smart homes, and now we're also looking at smart cities. For more, I encourage you to visit www.cupolatechnology.com. Now, Cupola and RapidValue became partners last year, and we are proud to work with RapidValue in the IoT domain. And before I start, I would like to thank Kavya for organizing this webinar. As mentioned by Kavya, I'll kickstart the presentation and we'll cover the first 3 topics in the first 20-25 minutes, followed by a presentation by Rakesh of another 20-odd minutes. And we'll leave the last 10-15 minutes for Q&A. So with that, let's get started. As again mentioned by Kavya, the first 3 topics deal with key trends in IoT. We'll talk about our approach to building intelligent assets. And we'll also talk about some of the top use cases. Now, if you're in the tech world and if you've not been living under a rock, I'm sure you've heard of the Internet of Things. By the way, it is also called the Internet of Everything, the Industrial Internet, Industry 4.0. There are many names. But whatever you may wish to call it, it is essentially about billions of new devices that will bridge the gap between the physical world and the digital world. Now these devices, new devices will allow us to monitor things that were not previously monitored. For example, if we install parking sensors to tell us if a parking space in a building is available or not. Now people can use that information to decide where to park their cars. Now these billions of devices are not going to be uniform. They will vary widely in terms of the parameters they measure and the communication protocols they use. Now some of them are going to be wired, however most will be wireless, a few of them will be powered by mains, but a lot of them will also operate on batteries. Now therefore in the Internet of Things we must learn to deal with a wide variety of devices. Now IoT is also about new business models. Now companies that adopt IoT will look at new ways of engaging with their customers. They will move away from what has been traditionally a one-time product sale to an ongoing continuous product as a service sale. Now, we will talk about some of these examples as we move forward. Finally, IoT is also about the convergence of information technology with the operational technology. In the manufacturing domain, OT refers to, say, a SCADA system. Now, traditionally, these two functions, which is IT and OT, have not interacted with each other and usually operate in silos. However, that is about to change thanks to IoT. Now, just to give you an example from the smart grid domain, a smart meter comes from the OT world, whereas the billing application is part of the IT world. Now, unless there is convergence and tight integration between the two systems, the electric utility will not be able to realize the benefit of a smart metering solution. Now, if we look at IoT in the industrial context, the first wave was all about mechanization, where large machines were introduced into production. The second wave came when the assembly line became popular. Now, it came first in the automobile industry and then in other industries. The idea was to mass produce cars and other items using the assembly line. The third wave was about using electronics and IT to automate the production process. Now, what we are seeing with IT-OT convergence is termed as the fourth industrial revolution or Industry 4.0. Before we move on, let's also look at some of the factors that are contributing to the growth in IoT. Now, today, both computing power as well as communication is available at low price points. Thanks to Moore's law, computing keeps getting better and cheaper every 1.5 to 2 years. By the way, a lot of people are predicting the end of Moore's law. But the point is this, computing resources have never been cheaper. Also, when it comes to communication networks, especially wide area networks, there's a lot happening. Now, telcos are pushing a new standard for IoT called NB-IoT, which is narrowband IoT, whereas there are other low power WAN options like Sigfox and LoRa. In fact, in India, Tata Communications is setting up a LoRa network across, I think, about 1,600 to 2,000 cities and towns. They've already done it in Mumbai, Bangalore, and Delhi, and you will see many more cities coming online with that LoRa network. So, in a sense, today both solution providers and customers have multiple options out there. Now, when we have billions of new devices in the field, they will obviously generate a humongous amount of data. Today, thanks to the widespread adoption of cloud and the big data infrastructure, we have a scalable mechanism to handle these large volumes. Now, at this point, let me also say that when we think about IoT as a layered architecture of devices, platforms, and applications, then our take is that the true value of IoT will lie in the ability to analyze and interpret that data. Finally, just as touch on a phone opened up a whole world of apps for us, new interfaces such as augmented reality will change the way we interact with the physical world around us. I'll move to slide number 4, and let's look at what some of the leading companies are saying about IoT. Now, McKinsey talks about operations optimization as a killer app within a factory environment. We would like to argue that operations optimization is a killer app in all enterprises and not just manufacturing. Now, for example, take the case of e-commerce companies, and we have a few of them here in India. These companies have large warehouses and equally large distribution networks. Today, almost all of them are evaluating IoT-enabled solutions such as RFID-based inventory tracking, automated sorting, warehouse management to make their operations more efficient while keeping costs down. Let's also look at Cisco. Now, Cisco talks about the Internet of Everything as a $19 trillion opportunity, and they allocate most of that $19 trillion, around $14.5 trillion, to the private sector. Now, the value at stake mentioned in the graphic is nothing but the direct impact on bottom line through increased revenue and reduced costs. Now, Cisco has identified some 5 key areas where maximum value can be realized within the private sector, and those areas are listed at the bottom of the slide. We'll come back to these areas in the next few slides. Another company that's quite vocal about IoT is GE. Now, we have not shown any graphic here to keep the slide simple, but according to GE, there are 3 pillars of industrial IoT. Now, one is intelligent machines. Now, these are machines with advanced sensors and controls. 2, advanced analytics, which is a combination of predictive analytics and automation. 3, and probably the most important one, people. That is connecting workers and employees with machines and then letting them use analytics to make better use of those machines. Now, GE also talks about the power of 1%. It is about how 1% into significant gain. For example, 1% saving in fuel for the airline sector will translate into $30 billion over 15 years. Now, similarly, 1% reduction in capital expenditure in the oil and gas domain will translate to some 90 billion US dollars in 15 years. Now here in these last few slides, we've shown you some numbers and dollar figures, and there are many more numbers out there. Almost everyone has their own estimate. However, if you were to ignore the numbers for a minute, you will notice that there is consensus on the tangible impact of IoT. And that impact is not restricted to one industry or one domain. We will see application of IoT from smart homes to smart cities, from a retail store to an automobile industry. And our view is that companies that take early advantage of IoT will be the biggest beneficiaries. I want to slide number 5 now, and by now you hopefully got an idea of the potential of IoT. However, the first question that will most likely pop up in your mind is, how can I make use of IoT, or how can I make my assets smart or intelligent? Well, let's try and answer that question here. And when we talk about assets, it can mean anything. Assets can be workers, employees, assets can mean equipment like cranes, trucks, street lights, or even something like an office chair. By the way, trust me, if you're interested, there's a connected chair solution out there, and we can build one for you. Now, if you want to add smarts or intelligence to your assets, then we would like to propose a simple connect, control, optimize framework. Now, this is just a guideline for your IoT journey. You can wish to go through all the 3 stages or stop at any time. The choice is entirely yours. Now, before we introduce a framework, let's imagine you're an LED lighting company looking to deploy a smart street lighting solution. In the first stage, connect, all you're looking to do is to add sensors and connectivity to your assets to monitor various operating parameters. So as a lighting company, you are interested to know if the lamps are on or off. Now, you may also want to monitor energy usage, for example. So for the first stage, it's all about monitoring. The second stage, control, is where things pick up. Now that you have connectivity and you're monitoring various parameters, can you control the asset? In the case of the lighting company, can you remotely switch off these lamps? Can you dim these lamps? Can you probably flash these lamps to indicate an emergency? So the second stage is about taking control of the asset from a remote location. Now, since we are talking about control here, we have to start thinking about device security, access control, and user management. Now, security remains a key imperative for IoT. You obviously don't want your assets to get hacked. Therefore, new security frameworks are being standardized by various bodies. Now, these frameworks take into consideration the fact that IoT networks are very different from IT networks. And therefore, new authorization and authentication mechanisms have to be designed that are more suited for battery-powered, low-compute IoT devices. The third stage, optimize, is where things get really interesting. Now, this is where we use analytics to optimize asset performance. So for a lighting company, you can figure out which lamps need replacement before they fade, or you can optimize the use of these lamps based on ambient light conditions, for example. Now, this is also a stage where machine learning and other advanced analytics can get used as we collect more and more data. The possibilities, frankly, are endless. To summarize, when you think about the journey, start with communication to connect, introduce control, and then use analytics to optimize. Again, please note this is a generic and a simple framework that we are proposing. Now, we have not covered the complexities, such as what should be the communication protocol in this use case, should it be a star network or a mesh network. The framework will not help you to answer these questions, but it will tell you what you need to do first in your IoT journey and what to expect at each stage. Now, let's look at some of the use cases of IoT. Now, in an earlier slide, we talked about 5 key areas where maximum value can be realized within the private sector. Now, these areas are good customer experience, which is all about better engagement and stronger relationships with your customers. Here, we will look at how business model innovation enabled by IoT is contributing to an improvement in customer experience. The second area is new tech innovation, which is all about adding new features to products and reducing the time to market. So here we look at improved safety and reliability. In the third use case, we will look at how supply chain optimization is helping to create process efficiencies. In the fourth use case, we look at how employee health and safety is contributing to a much safer work environment and therefore leading to an overall increase in employee productivity. In the final use case, we look at how condition-based maintenance is helping to improve asset utilization and therefore the life of the asset. So let's get started and we'll talk about each of them in a little more detail in the subsequent slides. So let's start with the first use case, which is business model innovation. And we will see how IoT has helped to improve customer experience. And here we look at DropCam. Now, DropCam, as you know, provides a video monitoring service to its customers. They capture value by charging customers a one-time fee for the camera hardware plus a subscription fee for different packages. The subscription fee is usually some X dollars per month or per year for a 7-day or a 30-day video backup. Now, DropCam is therefore not a hardware company, but rather a content provider. The content in this case happens to be home security and surveillance. And the innovation in the business model lies in monetizing the service rather than the product or hardware. DropCam was acquired by Nest, and which, as you know, is part of Google. Therefore, DropCam is now called NestCam. DropCam, by the way, is not unique. There are many more examples like this. For example, Whirlpool, the leading consumer electronics company, which also makes washing machines, has taken up IoT in a really big way. They're now looking at charging their customers for washing cycles rather than the washing machine. Also, if you look at the airline industry, there is a concept of the power by the hour model, which was first introduced by Rolls-Royce. Now, in this model, airlines, instead of an outright purchase, pay a fixed sum per flying hour for a jet engine. Now, companies like GE, Pratt & Whitney have followed the example set by Rolls-Royce and offer a similar model to their customers. Now, therefore, with IoT and connectivity built into the product, we are seeing more and more product companies moving away from a product sale to a product as a service sale. This kind of business model is beneficial and makes sense for the end consumer as well, because it means low upfront payment. It also guarantees superior ongoing service. Whereas for the product company, it means continuous engagement with the customers, or to put it a little differently, a continuous revenue stream. So in a sense, this is a classic win-win situation for all. Moving on, let's look at improved safety and reliability and how IoT devices can improve product safety. Now, Tesla electric cars are some of the most sought after cars in the US. Now, these cars are sought after not only because they are electric, then therefore environmentally friendly, but also because of the safety and reliability features. Now, in a typical Model S, there are 8 surround cameras providing 360-degree visibility with up to 250 meters of range. Apparently, there are also 12 ultrasonic sensors that complement these cameras. Now, in addition to all that, there is a radar with advanced processing that can see through heavy rain, fog, and dust. Now, this ultra-connected car with its sensor coverage takes the driving to a whole new level. And all this has become possible because of IoT and because of the low cost of sensors and the ability to do sensor fusion, which is to correlate data that is captured by multiple sensors. And of course, the availability of computing resources at low cost and therefore the right form factors has also obviously helped. I'll move to the next use case, which is around the supply chain management. Now, supply chain management is another area where IoT can play a big role. Now, the movement as well as the condition of assets along the supply chain is of prime importance to customers. Now, if you look at a company like DHL, they provide a range of services, including fleet management, where sensors can monitor driver behavior, the location of the vehicle, now, as well as the operating parameters of trucks such as fuel consumption, tire pressure, and engine performance. Using all these sensors, one can do things like real-time tracking, route planning, geofencing. To give you one example of a recent conversation we had with a client, this client was interested in monitoring the trailers of large trucks. Now, these trailers can be attached or detached from the main truck, and therefore there was no way to track those individual trailers. This client was interested in finding the geolocation of these trailers, especially when they're not attached to trucks. So that discussion is ongoing as we speak. Now, DHL also offers other services such as asset monitoring, and this is especially relevant in case of high-value shipments where the customer may want to monitor the shipment in real time. The customer may be interested in looking at parameters like vibration, temperature, humidity, and the various sensors inside the container help to provide this information and intelligence. Ultimately, the central idea here is that one must optimize the supply chain so as to bring in more process efficiency. I'll move to the fourth use case, which is around the employee health and safety, and which incidentally has a direct impact on employee productivity. Today, IoT is making information available to employees and field workers literally on their fingertips. Now, one such example is the Shell Smart Mobile Worker project, in which the Shell worker is equipped with a tablet device, a helmet fitted with a camera, and a voice integration that allows him to connect with the experts in the head office. Now, he can use these tools, and with those tools, he is able to address the field issues in a much more efficient manner. Now, at this point, let me also share that this kind of solution is very much in demand across enterprises in manufacturing, telecom, and retail. And we've had multiple discussions with clients about things like smart helmets and smart jackets. And one of our recent conversations revolved around a smart helmet using which a construction company wanted to track their workers inside the construction site. So there are many more examples like this. Finally, I should also mention that we are going to see the emergence of augmented reality in this area. Now, imagine a scenario where a worker has been asked to service a machine. Now, he puts on a headset with a display and approaches that machine. And as he points the display at the machine, all the key parameters about that machine appear in real time. Now, these parameters could relate to current readings, it could relate to the past issues and their fixes, it could probably provide him some suggestions, and you can well imagine the impact on productivity. I'll move to the final use case, where it's all about improving asset utilization through condition-based maintenance. And here we will talk about Schindler and their smart elevators. Now, the sensors installed inside these smart elevators, I believe, capture and transmit operating data such as vibration, speed, and temperature. Now, this helps in real-time fault detection, and that in turn reduces downtime and therefore minimizes convenience for the users. In fact, the intelligence built into the system allows for a maintenance workflow to be initiated even before the elevator breaks down. So here the condition of the asset is being continuously monitored to ensure that it doesn't break down or cause disruption of service. Now, Schindler is by no means alone in this. Kone, which is another elevator company, is also doing something similar. They have launched something called the 24/7 connected service, which uses a leading IoT platform out there to bring some new levels of flexibility to elevator maintenance. Now, in fact, Kone does not call itself the elevator company anymore. They are apparently in the people movement business. So these are some of the top use cases that we wanted to highlight today. The examples that we have shown are by no means unique. Also, the list of use cases here is not exhaustive. For example, we have not mentioned smart cities at all in these examples. Now, smart cities mean greater engagement between the city and its citizens and faster delivery of public services, while at the same time providing a better standard of living for the residents. As you may be aware, China and India are aggressively pursuing smart cities. It is estimated that there will be some 400 smart cities in China very soon. In India, the government has announced the 100 Smart Cities program, under which a lot of city councils are today looking at pilots and small deployments. Now, the typical use cases in a smart city will revolve around smart street lighting, security and surveillance, water management, waste management, and even something like smart parking. Now, all these use cases are going to be enabled by smart devices, a citywide network, interconnection between these different systems, and the ability to interpret large volumes of data. Now, while China and India are making a lot of noise about smart cities, there are already a few implementations and examples of successful projects in other regions. City of Santander in Spain is one, Songdo in South Korea is another. Therefore, smart cities present a huge opportunity for everyone in the ecosystem. However, we will not delve into that today. If you need more information on smart cities, Please reach out to us after this webinar. I'll pause now and request my friend Rakesh to take over. Rakesh, over to you. Thank you.
Thank you, Sudama, for setting the context on IoT and explaining in detail about the various commonly used application areas. So before moving on with the rest of the presentation, a quick introduction about me. I am part of the digital business consulting team here at RapidValue, and I lead the IoT solution and service line. So we as a company are focused on digital transformation, and we help our customers solve their business challenges using cutting-edge technologies like IoT. Coming back to today's topic, the moment we talk about IoT and what it can do to your business, the immediate next question is, how do we get started with IoT? So in the next few slides, we will talk about a good starting point for your entire IoT journey and an approach which, from our experience, we have seen to be very effective for building intelligent assets and deploying a production-ready IoT application. In today's world of changing market conditions, increasing customer expectations, and rapidly changing technology landscape, the planning horizon is totally rethought. Though a 5-year strategy put together from your boardroom is necessary, a more actionable roadmap is mandatory. Especially when it comes to technology initiatives, your next 5 quarters should resonate with your long-term business vision and objectives. With IoT, we recommend a 3 weeks plus 6 weeks plus 12 weeks approach, which will be your 5-month run-up to plan your next 1.5 years. This approach and set of activities will obviously vary from case to case, but for today's discussion's sake, we have generalized and simplified it so that it can serve as an indicative approach to help you get started and hit the road. The first 3 weeks is the strategize phase. IoT is usually a long-running strategic part of your business. So to kickstart your journey, a proper vision, direction, and plan is needed. Hence, this strategize phase is the most crucial and important period where essentially you do the work of identifying what is needed for your business and how IoT can fit the purpose. It typically starts with an assessment workshop. For the workshop, a small team is put together to drive the entire initiative. Partners with proven capabilities can augment your team and guide you through the process. Carefully assess areas or business processes that can be suitable candidates for IoT. Conduct detailed discussion on business objectives and your requirements. The team needs a very clear understanding of the current state and the desired state so that they would be able to analyze the gap. Identify various application areas and map these use cases with business objectives. Finally, prioritize this multiple use case and identify a suitable POC use case. A good practice at this stage is to develop a business case for your POC use case. You can consider all cost elements including the OPEX cost and also try to quantify the benefits to get your calculations right. Though it is time consuming, it is advisable to initiate this process during this phase. The next 6 weeks is what we call as the tryout phase or the pilot phase. This is where your entire POC project plan is fleshed out and POC application is developed. While you start defining the POC solution scope, it is advisable to keep the scope as minimum as possible. Think of it like an MVP so that it will be helpful for you to put together the requirements. Please note that the POC application is meant to be a testing ground, and hence keeping the requirement to a more direct, measurable, and straightforward use case will be good. While finalizing the requirements for the POC application, better skip integrations at this stage and look at it as a standalone application. Though you are skipping the integrations for requirements, but while you put together the architecture, incorporate future scope, integrations, and scalability requirements. This will help when designing the technology stack, the platforms that you will use, and the tools that you will use. Try to develop the application with readily available components and reusable frameworks. This is primarily to make sure you don't spend ages on developing a POC application. Finally, identify users and functional areas for a targeted rollout. This will make it easy during the next phase when we are measuring the results from the POC. Care should be taken in selecting the sample set so that it would represent the actual scenario. This way, the training needs, process improvement areas, and the feature changes would reflect your actual rollout rather than a best case or worst case scenario. Once the POC application development is complete, the next 12 weeks comprises of your final execute phase. The focus in this phase should be on two things: moving your POC application to production and drafting your broader strategy and roadmap. So the first one, moving your application from POC to production. Start defining metrics and measure results and compare these results against the expected outcomes. This should be an ongoing exercise throughout this period until you are very clear on moving the application to production. Make any changes, any customization, or any course correction that is needed at this stage. Obviously, production application will bring in a lot other complexities like your security requirements, your process orientation, various other external factors, and so on. So the POC solution needs to be bolted on with multiple layers to meet these requirements and become enterprise ready. For the second point of putting together a broader roadmap and a holistic strategy, IoT solution should be looked at along with other solution components and integrations. Identify other use cases, improvement areas, business objectives, and cross-functional requirements that can be suitable for IoT intervention. The IoT solution should work along with your other technology initiatives and should work in tandem with your existing landscape. So think of the technology strategy in which IoT solution will be a part. Start by putting together your entire next year roadmap and define key milestones. Follow up on the strategy by setting up an execution team, establishing clear processes, governance model, project plan, and budget allocation for the long-term roadmap implementation. As with any other initiative, track the progress continuously to innovate and bring in positive disruption to your business. Moving on to the next slide, I would like to talk about some of the key imperatives for success in this approach. We have seen in many cases, clients more or less overlook some areas in these and then realize the importance only after a retro. The 5 areas which must and should be given proper importance are business focus, user experience, technology, business metrics, and right partner. Business focus. More often, decision makers start off IoT initiative at a single process or at a functional level. The initial months get lots of focus from top management, and then gradually the focus shifts to other areas, leaving the IoT initiative in a state of lumber. So business focus doesn't stop just by setting up a strategy and roadmap. The top management and the responsible team should ensure that there's a top-down strategic commitment. A proper transition plan, change management plan should be in place to radically change your current process to an IoT-enabled process. The implementation should also consider training needs and the in-house talent requirements for the new ways of operation. User experience. User experience is traditionally associated with mobile applications. And when it comes to enterprise applications, people tend to take it for granted that enterprise application will be difficult to use. With rising millennials and digital natives in the working population, companies have to ensure enterprise applications have got the same, if not better, user experience as in a consumer app. The solutions identified should be looked at from different user profiles or personas perspective to ensure there is 100% adoption of the solution. Acceptance from your customers, your employees, and partners can only determine the ROI from your initiative. They need to focus on various user personas and map different functionalities to usability goals. Great UI and design plays a key role in the hardware design part also. Seamless and rich user experience should be designed for all levels of the solution for multiple form factors and for multiple delivery channels. The next piece, technology, which is the centerpiece of the puzzle around which all your other parts revolve. IoT brings in a lot of complexities via its multiple platforms, multiple protocols, multiple solution providers, multiple device manufacturers, and so on and so forth. So blueprint best practices, assess the various technologies, assess platform providers, infrastructure options, and choose the best fitting one that can interoperate with your existing portfolio. The selected option should be ideal for integration needs and your future performance and scalability needs. Some points to note in this area are the architecture decisions that you take should be after a careful evaluation and selection at each layer of the IoT solution stack, namely the device layer, connectivity layer, the application layer, and the integration layer. Standalone IoT system can never bring in the value it is meant for. core backend system integration is a must for deriving cross-functional insights. Always select development methodologies, tools, and platforms which can be supported internally in the future. Security is of utmost importance. End-to-end security, data privacy and encryption, access and authorization, auditing, protection across multiple protocols, your app and infrastructure hardening. There are a lot of various factors to consider when it comes to security. Business metrics. Metrics are important to understand where you are headed, how much distance you have covered, and is there any change required in the pace. Having a yardstick is very difficult in many cases, but benchmarking with internal functions or similar companies can be a good starting point. Use existing KPIs to understand what more is needed and put in new measurable metrics and set targets. Keep measuring your metrics religiously and compare it with defined targets. Finally, the right partner. I'm sure by now all of us would have got a hang of how deep the ocean of IoT can go. The complexities involved are in no means should be a roadblock to companies. IoT solutions usually depend on the strength of the entire ecosystem. The ecosystem consists of business or domain experts, hardware manufacturers, gateway providers, platform providers, analytic experts, and system integrators. There is no one company which can do everything. So choosing the right partner with the right ecosystem who can bring the right players at the right time is a necessity. Some companies have internal teams, but still it is advisable to bring in partners who can help them at least in the initial stages. While deciding on a partner, look at more strategic and long-term partners. Recommend and form a steering committee and program management office who will bring in proper process standardization and a proper governance structure. Ensure there is a clear channel of communication to put in coordinated efforts so that you can move forward as a team. In case you have any questions, we can definitely take them up for discussion at the end of the session. With this, I would like to hand over to Sudama to talk about the nitty-gritties in implementing an IoT solution.
Thank you, Rakesh. Now, we're coming towards the end of the presentation, and we understand that the implementation of an IoT solution can be challenging. And that is where RapidValue and Cupola come in. And, if you look at the graphic on the slide, it shows the three-tier architecture of IoT, which is the edge tier, the platform tier, and the enterprise tier. So we can work with you in one or all three of these areas. We can help you in terms of identifying the right components. We can work on the design and development of smart devices, as well as the applications that consume the data from these devices. By the way, we are also working on some of the leading IoT platforms out there. Some of the names are listed on the slide. So we can work on platform customization and enterprise integration. So whatever be your requirement in this IoT journey, you have essentially come to the right place. So with that, we have come to the end of this presentation, and we would like to open up the line for questions now, and I'll hand it over to Kavya. Thank you, Kavya.
Yeah, thank you, Sudama. Is there any questions? There's one question. So how do you ensure security for these billions of devices?
Okay, I'll take this. This is Sudama here. I'll take this question. As I mentioned in my presentation earlier, security is a key imperative for IoT. Now, if you look at the three-tier architecture of IoT, which is in front of your screens right now, the edge tier, the platform tier, and the enterprise tier, the security within the platform tier, the enterprise tier is well understood. The primary issue is around device security in the edge tier. Now, what is the challenge here? The challenge is these IoT devices are constrained devices, which means that they have low compute, less memory, they are battery powered. So the traditional IT security controls or protocols have to be adopted for IoT. Now, if you look at what is a typical device lifecycle, you have booting, you have registration of devices, you have data exchange, you have firmware updates. But if you were to implement a few key features, like an immutable hardware ID, which is nothing but a unique hardware ID for a device that can't be changed, and also look at something like secure boot, which is comparing the kernel image that gets loaded when a device is booted up with the stored image in the flash. and if there is no discrepancy, then the device essentially comes alive and gets registered. Similarly, there is whitelisting, which provides what is called agent level protection. It is essentially a list of agents that the device is allowed to run. So by implementing some of these key features, you can ensure device security. Now, obviously, this is a very important topic, and we may not have the time, and I may not have the expertise to cover this in detail. But I should mention that there is a lot of standardization happening in this area. In September of last year, I think the Industrial Internet Consortium released a paper talking about its recommendation for a security framework. That paper, I think, contains guidelines on how to implement device or endpoint security. I would highly recommend whoever has asked this question to go through that paper. Over to you, Kavya.
There's one more question. How do you choose an IoT platform?
So I would rather look at this question like which platform would be suitable for my application rather than which platform should I choose. So the platform decision should be primarily driven from the application requirements. So depending on any kind of features that is needed in terms of the data handling capabilities, in terms of enterprise features like the security, scalability, connectivity supported, also protocol supported by the platform. And there are few pure play platform vendors who offer very niche features or industry focused specific to a vertical feature. So those kind of assessments should be done to identify a suitable platform.
There's another question on, can I make my legacy assets intelligent?
Okay. The short answer is yes. However, there are a few things one must keep in mind. Firstly, why would one be interested in a legacy or what is, I think, called a brownfield asset, right? I assume it is because these assets provide some useful information. In that case, what would happen is that typically the legacy asset would get connected to an industrial gateway, and the data communication between the legacy asset and the gateway can be through open protocols. But obviously, if it is a legacy asset, it's possible that the legacy asset doesn't support open protocols. Then what do you do? Then you basically need a protocol converter between the legacy asset and the industrial gateway. So there are a couple of ways in which you can bring these legacy assets into the IoT world. Incidentally, we've done something like this a few times, and if you want more information on this, then my request you to get in touch with us after this webinar, and we'll be happy to share more info with you.
Another question on, how can assets in remote locations where connectivity may be a problem be monitored?
Okay. So now, yes, obviously there are some places where connectivity can be a challenge. In that case, the solution is that one can build out one's own field area network. Now imagine if you have a large home, sometimes getting Wi-Fi in every corner of your home is going to be a problem, right? So there, what do? We use repeaters, we use signal boosters. So here we have to do something similar. Actually, recently I heard about a company which manages large farms, and they were interested in deploying sensors in the field, the agricultural field. However, the connectivity was apparently restricted to just one corner of that farm. So what they did was they set up a LoRa network, which is a low power WAN option, and which is very similar to a cellular network in that it has a long range. So with one gateway, apparently they were able to cover an area within a 5-mile radius, at least theoretically. And once that network was up, they were able to deploy sensors and connect them to the LoRa network. Now, obviously, it is not as simple as I just described it, but you would, I'm sure, get the idea. So, if connectivity is a problem, the simple answer is set up your own network.
There's one more question on related to POC. So what are some of the challenges in moving from POC to production?
So again, for this specific question, the reasons may vary from various client to client and project to project. But the prima facie reason for not moving a POC application to production will be obviously the application not meeting the the set objectives. So the various root causes for that can be there would not have been enough metrics defined in the first place, or the cost benefit analysis of the entire application would not have been done, wherein the cost doesn't justify the ROI from the application. This can happen in a scenario where a lot of hidden costs, like your connectivity expense, your ongoing platform expense, those were not considered in the initial phase, and then during a POC phase, these costs are faced. And obviously, when it comes to a production rollout, there are a lot of external factors like environmental interference, various field conditions, and different users, various multiple use cases which were not initially thought of. So these can be various causes that can lead to the POC application not meeting the objectives.
Any more? Don't see any more questions. I think we have finished right on time. If there are any more questions, you can please write to contact us at rapidvaluesolutions.com, and one of us will respond back to you. Now, we will also email the webinar recording to all of you in a couple of days. Thank you once again for taking the time out to attend our webinar. I am sure it was useful to you. Thank you, Sudama and Rakesh, for a very informative session. Have a nice day.
Thank you, everyone.
Thank you, everyone.